Okay, so welcome back. Now in this video we're going to talk about the squeeze theorem for sequences. And so there are times where we're dealing with a sequence that we can't or are very difficult to ascertain whether it's convergent or divergent. And so if we can come up with two other sequences, one that's bigger and one that's smaller, that we know go to the same limit, they both converge to the same limit, then we can use this theorem to say that the third one, the one that we're trying to ascertain, the one that comes between them, has to be going to the same limit. Okay, and so that's the squeeze theorem. So the squeeze theorem says that if we consider three sequences, a sub n, b sub n, and c sub n, and suppose there exists an integer n such that we know that this is true for all n greater than or equal to n. Okay, so that the b sub n, the nth term, is between the nth term of the a sub n sequence and c sub n sequence. Okay. So that means, so if that condition is met, then if there exists a real number, L, such that the limit of a and the limit as n approaches infinity of a sub n, the nth term of this sequence, and the limit as n approaches infinity of c sub n, okay, go to L. So in other words, if these two sequences converge to the same limit, then b sub n must also converge to the same limit, and that limit has to be L as well. And this is called the squeeze theorem because you're basically taking a sequence that is larger than the sequence you're interested in, take another sequence that's smaller than the sequence you're interested in, and if those two sequences, the one on top and the one on bottom, are going to the same limit, then the one that's between them has to also be forced or squeezed to the same limit as well. Okay. So, proof. Let's prove it. Okay, first of all, the assumption is that we have these three sequences. Okay? So again, we start by letting theta be choosing an epsilon. So let epsilon be greater than 0. And since the sequence a sub n converges to 0, right? So again, we're assuming or supposing, so since the sequence a sub n converges to L. So what does that mean? By definition of being a convergent, series, then let's see. Since a sub n converges to 0, then there exists. So this is the symbol for there exists. Then there exists an integer n1 such that the absolute value of the distance of a sub n minus L is less than epsilon. Right? Also, since C sub n converges to L, there exists an integer n sub 2 such that the absolute value of C sub n minus L is also less than epsilon. Oh, hold on. I keep forgetting this. For all n greater than or equal to n1, for all n greater than or equal to n2. Okay, so for both of those, all we're using is a definition of a convergent sequence. Now, we're also assuming that there exists an integer n such that the inequality holds, right? So that's one of the things we're assuming, right? So we are assuming there exists an integer n such that a sub n is less than or equal to b sub n, which is less than or equal to c sub n for all n greater than or equal to n. Okay, so that's the assumption we're making, right? So now what we're going to do is, again, similar to the previous proof, we're going to say I guess it doesn't matter, but we'll call it M. So let M equal the max of n1, n2, and n3 and n. Okay, so we're going to let M be the maximum of those. Okay, and if that's the case, what must we show now? Well, what we need to show so we need to show that the absolute value of b sub n minus L is less than epsilon for all n greater than or equal to m. Okay, so that's what we need to show. Okay, well, what do we know for all n greater than m? Well, for all n greater than or equal to m, we know this. Well, we know that Okay, so since we're using absolute values, well, we know we can write this as negative epsilon is less than what? The negative of a sub n minus L, the negative of the opposite of the absolute value of n a sub n minus L, and that has to be less than or equal to a sub n minus L. Right? So because we're taking the negative absolute value of this, so that's going to be negative, right? So negative epsilon, this is going to be greater than this. Okay? This has to be smaller than this, less than or equal to. Okay, and this, because of, where is it at? Oh, because of this assumption, right? We know this has to be less than or equal to b sub n minus L, which also has to be less than or equal to c sub n minus L. Right? Which is less than or equal to the absolute value of c sub n minus L. Okay, so we've got this chain of inequalities, which we know this is less than, oops, getting my epsilons backwards. Okay, so we got negative epsilon and epsilon. Okay, so we know, so here's the purpose. We know for all n greater than or equal to m, right, so which is the maximum of these threes, we know then that this, right, is between negative epsilon and epsilon, right? So what are we trying to do? We're trying to say that this b sub n minus L is in between plus or minus epsilon. So we start with negative epsilon. We know negative epsilon is going to be less than the negative of this, right? Okay, because if we take away the absolute values, we have to say that this is less than epsilon or bigger than negative epsilon. So again, if we take the negative of both sides, we have to flip the inequality. Okay, so that means that if this is true, then this has to be true. Okay, so this is just using the property of inequalities. So we get negative epsilon is less than this. Okay, good. Now this is going to be less than or equal to this. Okay. And then of course this, and this all stem from this inequality, right? All we're doing is subtracting a constant L. So this should make sense. Okay? And then of course this is less than or equal to the absolute value of this. Okay? And then of course this is going to be less than epsilon because of what we said here. Okay? And because we're using m, which is the maximum of these three. Okay? And this is true for all n greater than or equal to m. So this inequality holds. Now, notice that that means that b sub n minus L is in between those two. So that's our next thing. So therefore, negative epsilon is less than b sub n minus L, which is less than epsilon. Hence, the absolute value of b sub n minus L is also less than epsilon for all n greater than or equal to n. For all n greater than or equal to m. And by the definition of convergence, we conclude that the series, or not series, sequence b sub n converges to L. And that's the end of it. And that's the squeeze theorem. Have a great day.